Architecture and organization. Computer architecture deals with the design of computers, data storage devices, and networking components that store and run programs, transmit data, and drive interactions between computers across networks and with users. Computer architects use parallelism and various strategies for memory organization to design computing system with very high performance. Computer architecture requires a strong communication between computer scientists and computer engineers since they both focus fundamentally on hardware design. At its most fundamental level, a computer consists of a control unit, an arithmetic logic unit (ALU), a memory unit, and input or output controllers. The ALU performs simple addition, subtraction, multiplication, division, and logic operations such as OR and AND. The memory stores the program's instructions and data. The control unit fetches data and instructions from memory and uses operation of the ALU to carry out those instructions using that data. The control unit and ALU together are referred to as the central processing unit or CPU. When an input or output instruction is encountered, the control unit transfers the data between the memory and the designated input or output controllers. The operational speed of the CPU primarily determines the speed of the computer as a whole. All these components, the control unit, the ALU, the memory, and the input or output controllers, are realized with transistor circuits. The operation of a computer once the program and some data have been loaded into RAM takes place as follows. The instruction is transferred from RAM into the control unit and interpreted by the hardware circuitry. For instance, suppose that the instruction is a string of bits that is the code for load 10. This instruction loads the contents of memory location 10 into the ALU. The next instruction said add 15 is fetched. The control unit then loads the contents of memory location 20. At this level, the operation of computer is not much different from that of a pocket or calculator. In general, programs are not just lengthy sequences of load, store, and arithmetic operations. Most importantly, computer languages include conditional instructions, essentially rules that say if memory location N satisfies condition E, do instruction number X next. Otherwise, do instruction Y. This allows the course of a program to be determined by the results of previous operations, a critically important ability. Finally, programs typically contain sequences of instructions that are repeated a number of times until a predetermined condition becomes true. Such a sequence is called a loop. For example, a loop would be needed to compute the sum of the first n integers, where n is a value stored in separate memory location. Computer architectures that can execute sequences of instructions, conditional instructions, and loops are called Turing-complete, which means that they can carry out the execution of any algorithm that can be defined. Turing completeness is a fundamental and essential characteristic of any computer organization. Logic design is the area of computer science that deals with the design of electronic circuits using the fundamental principles and properties of logic to carry out the operation of the control unit, the ALU, the input or output controllers, and other hardware. The arrangement of wires and gates that link inputs to outputs is determined by the mathematical definition of addition. The design of the control units provide the circuits that interpret instructions. Due to the need for efficiency, logic design must also optimize the circuitry to function with maximum speed and has a minimum number of gates and circuits. An important area related to architecture is the design of microprocessors, which are complete CPUs, control unit, ALU, and memory on a single integrated circuit chip. Additional memory and input or output control circuitry are linked to this chip to form a complete computer. These thumbnail-sized devices contain millions of transistors that implement the processing and memory units of modern computers. VLSI microprocessor designs occurs in number of stages, which include creating the initial functional or behavioral specification, encoding this specification into hardware description language, and breaking down the design into modules and generating sizes and shapes for the eventual chip components. It is also involved chip planning, which include building a floor plan to indicate where is the chip each component should be placed and connected to other components. Computer scientists are also involved in creating the computer-aided design tools that support engineers in the value stage of chip design and in developing the necessary theoretical results such as how to efficiently design a floor plan with near minimal area that satisfies the given constraints. Advances in integrated circuit technology have been incredible. For example, in 1971, the first microprocessor chip, Intel Corporation PAR-004, had only 2,300 transistors. In 1993, Intel's Pentium chip had more than 3 million transistors, and by 2000, the number of transistors on such a chip was 50 million. The Power 7 chip introduced in 2010 by IBM contained approximately 1 billion transistors. The phenomenon of the number of transistors in an integrated circuit doubling about every 2 years is widely known as Moore's law. Moore's law. Moore's law. Gordon E. Moore observed that the number of transistors on a computer chip was doubling about every 18 to 24 months, as shown in the logarithmic graph of the number of transistors on Intel's processor at the time of their introduction. His law was being obeyed. Fault tolerance is the ability of a computer to continue operation when one or more of its components fails. To ensure fault tolerance, key components are often replicated so that the backup components can take over if needed. Such applications as aircraft control and manufacturing processes control run a system with backup processors ready to take over if the main processor fails, and the backup system often run in parallel so the transition is smooth. If the systems are critical in that failure would be potentially disastrous, as in aircraft control, incompatible outcomes collected from duplicated process running in parallel on separate machines are resolved by a voting mechanism. Computer scientists are involved in the analysis of such replicated systems, providing theoretical approaches estimating the reliability achieved by a given configuration and processor parameters, such as average time between failures and average time required to repair the processor. Fault tolerance is also a desirable feature in distributed systems and networks. For example, an advantage of a distributed database is that data replicated on different network hosts can provide a natural backup mechanism when one host fails.